All right, let's jump right in. Have you ever really thought about how you decide if two colors are basically the same? Or if one sound is louder than another? I mean, it feels so simple, right? A snap judgment. But underneath all that, there's this fascinating and super complex system at work. And today, we're going to pull back the curtain and look at the strange, kind of warped ruler your brain uses to measure reality. And just a heads up, once you see it, you're not going to be able to unsee it.
It really all boils down to this one simple question. Think about it. When you're trying to match paint colors at the hardware store, or tuning a guitar, or even just arguing with a friend about whether their new car is the exact same shade of blue as the old one, you're always asking this question, even if you don't realize it. How same is same enough? And this isn't some deep philosophical thing. It's a real practical problem your brain is solving, like all day, every day.
So how do we solve it? Well, the answer is in this kind of internal ruler our mind uses. But, and this is the key, it doesn't measure in inches or centimeters or anything like that. Nope, it uses a completely different and frankly, way more interesting system.
Okay, so here's the absolute core of the idea. Your brain, it's not a calculator. It's not sitting there measuring exact units. It really doesn't care if one light is, say, 10 lumens brighter than another. It's asking a totally different kind of question. It's asking, is it twice as bright? Is it half as loud? See the difference? We are literally built to see the world in ratios, in relationships, not just in raw, absolute numbers.
And this mental ruler, this way of thinking, it actually has a name. It's called the logarithmic scale. Now, I know what you might be thinking, oh, math. But stick with me. It's not just some obscure concept from a textbook. It actually seems to be the fundamental model for how our brains work, how our cognition is structured. It shapes how we compare pretty much everything we see, hear, and feel.
So let's break that down. Here's how it works in practice. A normal physical ruler, well, it sees the difference between 1 inch and 2 inches as the exact same as the difference between 101 inches and 102 inches, right? It's 1 inch, period. But that's not how our brain sees it. To our minds, the jump from 1 to 2 feels huge, but the jump from 101 to 102, they feel practically the same. Why? Because it's the ratio, the proportion that our brain cares about, not the absolute number.
So there you have it. That's our cognitive ruler in a nutshell. It's a scale that's built entirely on relative differences, not on fixed absolute values. And this one simple idea, well, it has some truly mind-bending implications. And it all starts when you look at the limits of this scale. See, this cognitive ruler we all have, it's not infinite. It doesn't go on forever. It's actually defined by two theoretical limits, two extremes. And the crazy part is, our minds can get closer and closer to them, but we can never, ever actually reach them. Okay, so what are these limits? Well, on one end, you've got absolute equality. Think of this as a perfect theoretical ideal. It's not a real thing you can touch, it's the pure idea of something, like the perfect concept of the color red in your mind. Then, on the complete opposite end, you have absolute indiscernibility. And that's just the fire hose of raw, messy, sensory data hitting your eyes before your brain has had a chance to make sense of it, before it's even labeled it red. It's pure sensory chaos. And this visual really just illustrates the whole system perfectly. All of our actual thinking, all our measuring and comparing, it all happens right here, in the middle on that cognitive scale. We're in this constant dance, moving away from the chaos of raw experience and trying to get closer to the clean, perfect order of a theoretical idea. But we never quite get to either end. Our entire mental life, it happens in that space between. So that brings up a huge question, right? If we can never actually reach that perfect absolute certainty of a theory, then how in the world do we create things like scientific laws, or even just simple everyday rules? Well, this model gives us an incredible answer. We don't walk there, we jump. And this idea was actually described beautifully by the thinker Henri Poincaré. He's the one who called it the discontinuity jump. And it's exactly what it sounds like, a necessary cognitive leap we all have to make to get across the gap that separates all that messy, real-world data from a clean, simple theory. This process, this jump, is basically how knowledge gets made. Let's walk through it. First, you start with a big cloud of messy data. You're watching apples fall from trees. You're tracking how planets move. You're watching things roll down hills. All the data points are similar, sure, but they're never, ever perfectly identical. Then, you make the cognitive leap, the jump. And what do you land on? A clean, elegant, simple law like F equals ma. You've literally jumped from the messy world of experience to the clean world of theory.
Okay, so you might be thinking, this is a cool abstract model, but why does it actually matter? Well, it matters a lot, because it fundamentally changes how we should think about knowledge itself. It reveals the very nature of how we build understanding out of out of raw experience.
All right, let's wrap this up and put all the pieces together. What have we learned? We've seen that our minds measure the world using this strange relative logarithmic scale. We've seen that this scale is stuck between two ideals we can never reach, the pure chaos of experience on one end and the pure perfection of theory on the other. And to get from the messy data to a clean idea, to actually create knowledge, we have to take this leap. And here is maybe the most important takeaway of all. That gap we're jumping across, it isn't a bug. It's not a flaw in our thinking. It's a fundamental feature of how our minds work.
And all of this leaves us with one last pretty powerful question to chew on. This model shows us that our neat, clean theories and our messy, complicated reality are always going to be separated by this cognitive leap. So, if our knowledge is always a jump away from direct experience, what does it really truly mean to know something? That's something to think about. Thanks so much for joining me.